In these problems, we are finding derivatives of some fairly complex expressions that include natural log. And the thing to know, if f of x is the natural log of x, then the derivative of that is 1 over x. So that's the rule for the derivative of the natural log. And then we've got, in this case, we've got something more complicated. We've got the natural log of the square root of 6 minus x. And there are actually a couple of ways you can do this. One would be with applying the chain rule sort of multiple times, and I'm going to need some room to do that, so I'm going to rewrite the thing over here. So f of x equals the natural log of the square root of 6 minus x. So let's try this with the chain rule. What I want to do is set u equal to this square root of 6 minus x. I'm going to write it as 6 minus x to the 1/2 power. Same thing as square root of 6 minus x. And now we can take the derivative of the natural log of u. To do that, you're going to get 1 over u times u prime. So that's our chain rule. Well, we know what u is, so we've got 1 over the square root of 6 minus x. So 6 minus x to the 1/2, same thing, times the derivative of u. Well, what's the derivative of u? I think here we're going to have to use the chain rule again. I'm going to call, let's say v this time, since we've already used u, 6 minus x. So now I've got v to the 1/2 power, and taking the derivative of that is pretty easy. That's 1/2 times v to the negative 1/2. And then we can plug v back in. We get 1/2 times 6 minus x to the negative 1/2. And that's this thing, so it's going to be multiplied here. Oh, wait, but we also need the derivative of the inside multiplied. So it's times v prime. And v prime, well, the derivative of this 6 minus x is just going to be negative 1. So times negative 1. So all of that gets multiplied here. So I've got 1 over 2 times the square root of 6 minus x, and all of that times a negative 1. I think we can do some simplifying here. We've got 2 square roots of 6 minus x on the bottom plus that 2. So that's just going to be 2 times 6 minus x. And let's put the negative out front, and we've got that. So that's pretty simple. I want to show you one other way to do this, and it might be simpler, and that's by using a property of logs. So let me start the problem again. So our f of x equals the natural log of the square root of 6 minus x. Now, I'm going to rewrite this as the natural log of 6 minus x to the 1/2 power. With logarithms, you can take that power and multiply it out front. So this is going to go out front here. So this is 1/2 times the natural log of 6 minus x. Now, we don't have to use the chain rule twice because we use that property of logs. And hopefully this comes out to be the same thing, but let's try it. Let's make u equal to 6 minus x. And so we're going to take the derivative of, well, 1/2 times the natural log of u is going to equal 1/2 times 1 over u times u prime. And u prime here, the derivative of this expression, is just negative 1. So we've got 1/2 times 1 over u. So let's put this 1/2 times 1 over, let's put u back in here. We said u was 6 minus x, and times negative 1, which is our u prime there. And this is looking a lot like this. Yeah, if we put the negative sign out front, we put the 2 snugged up there, we've got this expression exactly. All right, we're going to try one more. These are long and difficult, but we're going to try them. Here we've got x times the natural log of x over 5x plus 9. And probably the way to do this is with the quotient rule. I don't really see an alternative for this. So I remember the quotient rule by that silly little rhyme, low d high minus high d low over low squared. So low d high, so the derivative of this thing. I'm going to wait a second on that. That's going to go in there. So low d high minus high d low, so x ln x. And d low, that one's pretty easy. That's just 5x plus 9. You're just going to get 5 here. All over low squared, so 5x plus 9 quantity squared. Now I waited on this one, the derivative of the top, because this is a product. So we're going to have to use the product rule inside the quotient rule. So the product rule says you can take the first thing times the derivative of the second thing. So derivative of the second thing, the natural log of x is 1 over x, plus the derivative of the first thing, which is just 1 times the second thing. Okay, and simplifying here, these x's cancel out. We actually get 1 plus natural log of x. And I guess, I'd probably put this 5 out front here, but I don't think this pays to do a bunch more simplifying, honestly. So I'd probably send it in like this, and I think ALEKS would be okay with it. So that is a little bit of work with some fairly complicated derivatives using logarithms and algebraic functions.